In 1856, engineers in Chicago accomplished something that modern construction experts call functionally impossible. They reversed the flow of the Chicago River, not diverted, reversed. And they did it using hand tools, horse-drawn equipment, and labor crews in less than 3 years. But that's just one city. Between 1820 and 1860, over 4,000 miles of canal systems appeared across the continent. Stone-lined, multi-level lock systems, some carved through solid bedrock. The official story says these were built by immigrant laborers with shovels and pickaxes. The engineering record says something else. This is the story of a water infrastructure network that appeared too fast, worked too well, and vanished from our maps within a single generation. By the end of this investigation, you'll understand why these systems were abandoned almost overnight, and what their existence suggests about the civilization that built them. Because if they were built in the 1850s, we need to explain how. And if they weren't, then whose infrastructure were we really using? Let's start with the accepted narrative. In 1817, the state of New York authorized construction of the Erie Canal, 363 miles connecting the Hudson River to Lake Erie. According to records, it was completed in 1825. 8 years, entirely hand-dug. The project is celebrated as one of the greatest engineering feats of the 19th century. It opened the American interior to trade. It made New York City the commercial capital of the nation. Following its success, dozens of other canal projects launched across the Midwest and Northeast. The Ohio and Erie Canal, the Wabash and Erie, at 460 miles, the longest in North America. The Illinois and Michigan, the Chesapeake and Ohio. By 1850, the continent had been laced with thousands of miles of navigable waterways. The story is simple: American ingenuity, immigrant labor, and economic necessity. But when you examine the technical details of what was supposedly accomplished, the timeline starts to fracture. Let's focus on one feature: the locks. A canal lock is a controlled chamber that raises or lowers boats between different water elevations. To work reliably, the chamber walls must be perfectly watertight, the gates must seal under pressure, and the entire structure must withstand decades of hydraulic force. The Erie Canal alone required 83 locks, each one built from hand-cut limestone blocks, some weighing over 2 tons, fitted so precisely that many required no mortar. Now here's where the official timeline encounters a problem. According to project records, the peak labor force on the Erie Canal was approximately 9,000 workers. 9,000 workers, 363 miles of canal, 83 lock systems, 8 years. That's an average of 45 miles excavated per year, across swamps, through forested hills, over rivers, under the Mohawk Escarpment, with shovels and wheelbarrows and black powder for blasting, which was expensive, dangerous, and in limited supply. Modern engineering analysis estimates that recreating the Erie Canal with the same tools would require closer to 15 to 20 years, assuming ideal conditions and zero delays. But that's just one canal. Between 1825 and 1855, over 30 major canal systems were under simultaneous construction. Let me restate that. During a 30-year window, while the United States had a population of under 30 million, most of them farmers, tens of thousands of miles of precision stonework infrastructure appeared across the continent. In the same era when it took 6 months to travel from New York to California. In the same era when most roads were dirt paths. In the same era when the tallest buildings were 3 stories high. And yet, somehow, this civilization, using hand tools, engineered a water transportation network more extensive than anything that exists today. So let's dig deeper, because there's a detail in the construction records that nobody talks about. The canal beds weren't dug into virgin soil. They were excavated into pre-existing drainage systems. In the 1970s, during restoration work on the Ohio and Erie Canal near Akron, engineers discovered something unexpected beneath the 1830s construction layer: a second foundation, older, constructed from a different type of limestone, with tool marks that didn't match 19th century methods. The restoration report, filed with the Ohio Department of Natural Resources, noted unknown prior construction and evidence of earlier drainage engineering. The findings were cataloged, briefly mentioned in a technical appendix, and never investigated further. If the canal routes followed pre-existing channels that were already stone-lined, already graded for water flow, then the 1820s construction crews weren't building these systems, they were restoring them. And when you map the major canal routes against natural watershed drainage, they align too perfectly. Not like someone plotted the most efficient course, like someone remembered where the channels used to be. But if these canals were restorations, what happened to the originals? And more importantly, how did 1820s engineers know exactly where to dig? The lock systems demonstrate engineering knowledge that didn't officially exist yet. Let's talk about the gates. Canal lock gates use a design called a miter gate, two angled panels that meet in a V shape, pointing upstream. Water pressure forces them closed, creating a seal. It's a brilliant design, self-sealing, mechanically efficient, and according to engineering history, it was invented by Leonardo da Vinci in the 15th century for the canals of Milan. The knowledge was refined in Europe over 300 years, primarily in France and the Netherlands, before appearing in early American canal projects. Here's the issue. The miter gates installed on American canals in the 1820s to 1840s weren't crude early attempts. They were already perfected, tolerances within millimeters, gate angles optimized for hydraulic pressure, iron strap hinges with precisely machined pivot points. These weren't experimental designs being tested in the field. They were mature technology being replicated. In 1820, the United States had virtually no formal engineering schools. The first civil engineering program at Rensselaer Polytechnic Institute wasn't established until 1835. The Erie Canal was designed in 1817 by a lawyer and a judge. DeWitt Clinton, politician; Benjamin Wright, lawyer and surveyor, with no formal engineering training. And yet the system they designed featured lock mechanics that European engineers had spent centuries perfecting. No prototype phase, no trial and error, no iterative refinement, just fully functional, mature infrastructure. Which raises an uncomfortable question. Were they designing these systems or reverse engineering them? The rate of construction defies the physical limitations of the tools available. Let's do the math. The Erie Canal was 40 feet wide at the top, 28 feet wide at the base, and 4 feet deep. That's an average of 34 cubic feet of soil removed per linear foot of canal. 363 miles equals 1,916,640 feet times 34 cubic feet per foot equals 65 million cubic feet of excavation. 65 million cubic feet by hand in 8 years. Modern excavation studies estimate that a laborer with a shovel working a 10-hour day can move roughly 8 to 10 cubic yards of soil under ideal conditions. That's dirt, loose soil, not clay, not bedrock, not swamp muck frozen half the year. At peak efficiency, one worker could excavate about 270 cubic feet per day. 65 million cubic feet divided by 270 cubic feet per day equals 240,740 worker days. If you had 9,000 workers, that's 27 days of non-stop digging. Except this wasn't ideal dirt. The Erie route crossed the Montezuma swamps, miles of wetland requiring drainage and timber foundation. It passed through the Irondequoit Valley, requiring a 245-foot embankment. It cut through bedrock ridges near Lockport, and the workers weren't digging non-stop for 27 days. They worked seasonally. Weather delays, equipment failures, illness, injuries. Modern civil engineers estimate the realistic timeline for the Erie Canal using period tools at 15 to 20 years minimum. It was completed in 8. Now multiply that impossibility. The Wabash and Erie Canal, 460 miles, completed in stages between 1832 and 1853. The Ohio and Erie, 308 miles, finished by 1833. The Pennsylvania Main Line Canal, 395 miles, including the Allegheny Portage Railroad, finished by 1834, all happening at the same time, with overlapping labor pools, competing for materials, competing for funding. If one canal is borderline impossible, 30 simultaneous canals is a statistical anomaly, unless the infrastructure was already mostly there, and the construction was actually excavation, clearing, and repair. But if that's true, then where did it come from? And why does the historical record pretend it was all built from scratch? The canal networks were abandoned far too quickly for systems that cost tens of millions of dollars to build. The Erie Canal reached peak traffic in the 1850s. By 1870, just 20 years later, usage had plummeted. By 1900, most canals were abandoned. The official explanation: railroads. The railroad was faster, more flexible, and could operate year-round. Canals froze in winter. Railroads didn't. But here's the problem with that explanation. The Erie Canal cost $7 million to build in $1825. Adjusted for inflation, that's over $200 million today. The Ohio and Erie, $4.5 million. The Pennsylvania system, $10 million. Across the entire canal network, an estimated $200 million in 1850s dollars, roughly $7 billion in today's money. That's not infrastructure you just walk away from, especially when many of the canals were still profitable. The Erie Canal generated toll revenue every single year through the 1870s. It was making money, and yet maintenance budgets were slashed. Locks were allowed to decay. Channels silted over. The railroads didn't fully replace canal traffic until the 1890s. That's 40 years after the canals started being abandoned. There was a gap, a 20 to 30-year period where the canal systems were neglected, even though they were still economically viable. It's as if the infrastructure was deliberately phased out, not because it stopped working, but because its existence raised questions. What kind of questions? Let's look at the maps. The canal routes align with a continent-wide grid system that predates modern surveying. When you zoom out and look at the canal networks as a system, you see something remarkable. They're not random. They're not just connecting nearby cities. They form a hydraulic grid, linking the Great Lakes to the Mississippi River, the Ohio River to the Atlantic, the St. Lawrence to the Hudson. The Welland Canal, connecting Lake Erie to Lake Ontario, bypasses Niagara Falls. The Rideau Canal, connecting the Ottawa River to Lake Ontario, creates a military supply route. The Illinois and Michigan Canal, connecting the Great Lakes to the Mississippi Basin, opens the entire interior. Together, these canals create a navigable water route from New York City to New Orleans, from the Atlantic to the Gulf of Mexico, and the engineering required to design that system, to calculate elevations, lock placements, watershed drainage, seasonal flow rates, would require a continent-scale hydrological survey. The U.S. Geological Survey wasn't founded until 1879. The tools to perform precise elevation mapping across thousands of miles didn't exist in the 1820s. Surveyors used chains, compasses, and basic sextants, local measurements, not continental-scale datasets. And yet the canal systems were designed as if someone had access to a master map, a map that showed the entire watershed, the underlying drainage systems, the optimal routes, as if the infrastructure wasn't being planned, but remembered. So, where did the map come from? And who built the system it was documenting? Let's talk about what these canals actually were. The official narrative calls them transportation infrastructure, cargo routes, trade highways. But when you study the design, they were far more sophisticated than that. The canals weren't just for boats. They were integrated water management systems. The Erie Canal fed drinking water to Buffalo, Rochester, Syracuse, and Albany. The Ohio and Erie powered mill systems in Cleveland, Akron, and Columbus. The Illinois and Michigan supplied Chicago's early water grid before the reversal of the Chicago River. These weren't just cargo routes. They were the hydraulic backbone of entire cities, and they worked flawlessly. No pumps, no electric motors, just gravity, elevation, and precision engineering. Every lock gate, every sluice, every overflow channel manually operated. But the design of the control systems, how water pressure was balanced, how flow rates were regulated, suggests an understanding of fluid dynamics that was theoretically ahead of its time. The first formal treatises on hydraulic engineering didn't appear in the U.S. until the 1840s to 1850s. and yet the canals built in the 1820s already applied those principles, as if the knowledge came first and the textbooks came later. What if the canal systems of the 1850s weren't new construction? What if they were the remnants of a much older, much larger water grid, one that spanned the continent? A grid built by a prior civilization, damaged or buried by time, weather, or deliberate destruction. And what we call the Canal Era was actually a restoration era, an effort to excavate, repair, and reactivate infrastructure that had been abandoned decades or centuries earlier. That would explain the speed, the precision, the mature technology, and it would explain why the systems were abandoned so quickly. Because once the railroads arrived, there was no longer a need to maintain the illusion. So what happened to the canals? Between 1900 and 1920, hundreds of miles of canal infrastructure were deliberately filled in, not abandoned, erased. Urban development, sanitation concerns, railroad expansion. The canals were old, obsolete, in the way of progress. But here's what's strange. When canals were filled in, they weren't removed. They were paved over. In many cities, modern streets follow the exact paths of buried canals. Canal Street in Manhattan, Broad Street in Columbus, long sections of Chicago's urban grid. The roots are still there, just hidden. Occasionally, during modern construction projects, crews uncover sections of the old canal walls. Perfect stonework, still watertight, still functional. And every time, the discovery is cataloged, photographed, and reburied. Not preserved, not studied, reburied. Because acknowledging those structures raises a question that the historical narrative can't answer. If this infrastructure is so well built that it's still intact after 150+ years underground, how old is it really? And who built it? Here's where it gets wider. The canal networks of North America aren't unique. Between 1800 and 1870, canal construction boomed worldwide. The British Canal Network, 4,000 miles, mostly built between 1760 and 1830. The French canals, connecting the Atlantic to the Mediterranean, completed in the early 1800s. The Grand Canal of China, extended and restored during the Qing dynasty. Every major empire, every industrializing nation, all building canals, all at the same time. And when you map these systems against older geographic features, they align with pre-industrial trade routes, ancient riverways, even older Roman and pre-Roman aqueducts, as if every civilization was following the same blueprint, not inventing, restoring. The Rideau Canal in Canada, built between 1826 and 1832, features lock systems nearly identical to those on the Erie Canal. Same design, same precision, same mature technology. The Canal du Midi in France, officially completed in 1681, uses mitre gates and stone lock chambers identical to 19th century American designs. Different countries, different centuries, same engineering. What if the canal networks weren't independent national projects? What if they were fragments of a global hydraulic system built by a prior advanced civilization that spanned continents? And the canal era of the 1800s was humanity rediscovering, excavating, and reactivating pieces of that system, not building it, finding it. So what does this mean? The canal networks of the 1850s accomplished something that shouldn't have been possible with the tools, knowledge, and resources available. They appeared too fast. They worked too well. They were abandoned too quickly. And their design suggests access to engineering knowledge that hadn't been formalized yet. These systems weren't built from scratch by 19th century laborers. They were restored, excavated from older, buried infrastructure, cleared, repaired, reactivated. The builders of the 1820s to 1850s didn't invent the routes. They followed them because the channels were already there, beneath the soil, beneath the silt, beneath the flood layers and forest growth, waiting to be rediscovered. If that's true, it means the history we've been told about American ingenuity, immigrant labor, and the triumph of industrial progress is a narrative built on top of someone else's infrastructure. And it raises a question that no one seems willing to ask. If these canals are restorations, what happened to the civilization that built the originals? Why were the canals abandoned so quickly after being restored? Why were so many deliberately filled in and paved over? Why does the historical record insist these systems were built from scratch when the engineering evidence suggests otherwise? And why does every discovery of older foundations beneath the canals get catalogued, archived, and buried again? The infrastructure is still there, beneath the streets, beneath the cities, perfectly engineered, still intact, waiting for someone to ask the right questions. The canal networks of the 1850s moved more water than any system before or since, and then they vanished. In 1893, Chicago hosted the world's Columbian Exposition. 200 buildings, 600 acres, constructed in under 2 years, and when the fair ended, they burned it all down. The official story says it was temporary, plaster and wood frames. The photographs say something else.